Welcome everyone to tonight's Mission Control, Thursday, December 14th. We got some special guests tonight, and thanks for all the attendees for joining us once again. With this Mission Control is going to reach out hundreds of people, which we send out on our YouTube page, and we'll be recording it for further purposes. So starting off with our rules of engagement for tonight's Mission Control, like we do for everyone. We want to make sure everybody treats each other with dignity and respect. We'll have a chance to answer questions or ask questions from the panelists, attendees. If you'd like to submit your questions in the chat, we'll get to those as quickly as we can. And tonight we're honored to have Mr. Doug Backinger speaking to us about casters as an ergonomic solutions in material handling. After he's done with his presentation, we'll have a chance for questions both in the presentation and at the end, and then we'll have a few words from Steve. And now we'll go ahead and I'll stop sharing my screen and pass it on to Mr. Doug Backinger if you want to give us a quick intro about yourself and then get on to your presentation. Thank you.
Sure. Thanks, Ray. Thanks, Steve. I appreciate the invite. So my name is Doug Backinger. I'm the Vice President of Sales at Caster Concepts. I got a slide in my presentation where I kind of give some more background. But essentially, I've been in the caster industry since I've graduated college. When I started here as an intern, I had really no idea what a caster was when I walked in the door. But now I've been fortunate enough to design a lot of casters, test a lot of casters, and be out in the field to solve a lot of problems.
Awesome. We're excited for your presentation.
Yeah, thanks. Can you see it okay?
Yep, I can see it. If you want to go to present mode, that works too.
Yeah. Perfect. You see present mode?
Not yet.
How about now?
There we go. Perfect.
Perfect. All right. So like Ray said in the introduction, what I'm going to be talking about today is the importance of casters and the impact they can play on material handling in terms of improving ergonomics. So a little bit about Caster Concepts. So we've been in business now for about 40 years, located in Albion, Michigan. That's where our factory's at. We make everything within these walls, and we're proud to say that we're made in Michigan and made in the USA. And really our niche in the caster world is solving difficult material handling problems. So like Steve alluded to earlier, casters are on tons of different things, but we're specializing more in industrial applications, say 500 pounds up to 200,000 pounds. And we don't necessarily specialize in like off-the-shelf solutions. It's more we go and evaluate what's going on and tailor a solution to you. And like I said earlier, so I've been with the company 17 plus years. I started as an engineer, so I spent my first half of the career doing product design, testing, got to move into operations, so I learned how everything was made, and then the last 4 years now, I've been leading the sales team. So, well, I assume everybody here knows what ergonomics is. Start with a quick definition. So this is from the Material Handling Institute. Ergonomics is the science that seeks to adapt work or working conditions to suit the abilities of the worker. They also have a list of 10 principles. So we just highlighted 2 important ones to us, and that equipment should be selected that eliminates repetitive and strenuous manual labor, and the material handling equipment should be designed so it's safe for people to use. Now, the problem with casters is usually it's the last thing people think about. So they have their cart, they have their dolly, they have whatever they're trying to move. They put casters on the bottom, and then it doesn't work the way they want it to work. So why are more and more companies talking about ergonomics? You know, you can do a Google search, you can get all sorts of different numbers on overexertion injuries. The main point is it costs companies a lot of money every year. And from what we see, we think it's only going to get worse. So with this move to electric vehicles, what we're seeing is parts are getting heavier, the batteries are heavier, and where an automotive facility used to be able to get away with a bunch of carts that weighed, 1,000 pounds, 1,200 pounds, now we're seeing carts that weigh 2,000, 2,500, 3,000 pounds, and they can't exactly go out and hire a bunch more people to move it. So they're trying to find solutions to be able to move that type of weight safely with one person. And what I want to educate people on today is a lot of those problems can be solved just by using the right caster. So what we typically see in industry is companies come up with some sort of safety standard on push forces. So where a lot of these have come from, Liberty Mutual back in, I think, the 70s, developed this risk table. Some people might know them as the Snook tables. And basically what it does is you put in a push force that somebody is going to do multiple times a day, and it will tell you basically how safe that is as a percentage of the population. So for example, you have something that takes 70 pounds to push, that's only going to be safe for about 38% of the population, which, so for every 100 employees you have, 62 are at potential risk of injury. So you can see if you can reduce that to 50 pounds, you have a big jump in the percentage of that safe force. Now you're up to 82%. And the main standard we see in industry, I'd say probably 80–85% of companies are somewhere in the 40-pound range, some 45, some 35, but that gets you to 90% plus. So the tables don't say anything's 100%, but it will say 90% plus, and that's the best the table will give you. So that's the main standard that we're seeing in industry. So depending on whether you have 1,000 pounds or 3,000 pounds, you need it to be 40 pounds or less to start moving as a max force. So what I want to educate people on is how can you choose a caster to be able to help you get to that 40-pound number? And the things I'm going to talk about tonight, so the caster rig itself, so there's a couple important features. The wheel design, the actual wheel material or the tread, and then once you have all that, how do you put it on your cart? So with the caster rig, there's really two main things we're looking at. And the first one is the swivel section design. So that's the rotating, the bearing element that allows the caster to swivel or pivot. And then the swivel lead or swivel offset. So that if you look at the center line for where the caster pivots, that's the distance between that center line and then where the wheel is located. And you need to optimize one before you can optimize the other. So with the swivel section, kind of the original caster technology was a kingpin style caster. So if you go to Home Depot or Lowe's and you're going to buy a caster, this is the type you're going to see. They're typically made from stamped components or sometimes a forging that's been heat treated, but essentially they have a central kingpin that you then fasten with a nut or some sort of staking or swedging operation to hold everything together. So the drawback to that is, one, if you're using the nut to tighten everything together, you're putting drag on that swivel section, which makes it harder to rotate. And then just in terms of manufacturability, you're using some form of steel that can be welded. And really, if you want the best bearing element, you want high-grade steel that's been heat treated and that's been manufactured in a very precise manner to remove any sort of the slop or play that might load it unevenly. So with this design, it's easy to produce, but you're giving up a lot in terms of how it moves. So in the 70s, this kingpinless style came out. So this got rid of the kingpin, but still kind of similar drawbacks. You're manufacturing your own bearing element. You have to choose a steel that can be welded, so you can't quite heat treat it to the degree that you would if you went out and bought, an off-the-shelf ball bearing or tapered bearing. So while this was an improvement over the Kingpin, there was still some room to advance here in terms of swivel section design. So what's been around the last 15, 20 years or so is this maintenance-free design. So that uses a totally separate bearing element. In this case, it's a sealed ball bearing. So now you can optimize the steel you want to use, you can optimize the heat treat, and instead of having to weld it to your fork, you can press it all together. And now you've kind of optimized the swivel section design in terms of a precise bearing element. So these things are manufactured to 0.010 of an inch. They use bearing grade steel and they heat treat it to, somewhere in the 55 to 60 Rockwell C range. So now you're spreading out that load more evenly. You have a better wear surface, and you get a swivel section that rotates much easier under load. So the one drawback would be is as you scale this up to larger sizes, those bearings get much more expensive, and usually it becomes more cost efficient to use, say, a kingpinless style. So now that we've talked about the swivel section, the next thing you need to optimize is the swivel lead. So the general rule of thumb is the longer that swivel lead is, or the further that wheel is away from the center of pivot, the easier that caster is going to swivel. So think about if you had a lever, it's simple mechanical advantage. If I have a longer lever, I'm going to be able to turn something much easier than if I have a short lever. Same principle applies here, but in this case, there's an optimal swivel lead. So the problem with extending that lead out is now you're putting, a greater moment arm on this swivel section. So as you extend that out, you're putting more and more stress on the swivel section, which then makes it harder to swivel. So what we found in our testing is there's an optimal swivel lead that you want for the caster that you have, the swivel section that you have. And if you go beyond that, then performance drops off very rapidly. Next, your wheel design. So the first one's pretty obvious. So with wheel diameter, the larger the wheel, the easier it's going to roll. There's formulas, out there that you can calculate real quickly that if I go to an 8-inch wheel versus a 6-inch wheel, it's something like 25 or 30% easier to roll. But the downside to that is you might be saying, well, I'll just use the biggest wheel I can. I will go to a 24-inch wheel. In this case, we're talking about carts that people are pushing, that people are working off of, and people have an average height. So to keep things still in an ergonomic position, you're kind of limited on how large of a wheel you can use. So even though bigger is better, it doesn't necessarily always mean that it's the best solution overall. The next part of the wheel that I'll talk about is the wheel width. So this one's a little confusing because if you're talking about just getting a wheel to start rolling, the wider the wheel, the better. And I'll kind of illustrate this here on this image. So if you look at this red wheel here and say, that's a wide wheel, it's flat face, the entire surface is in contact. And then you look at this green wheel that's balloon tread, that would match up more to this image on the right for the narrow wheel, because you have a much smaller contact patch. So, or not smaller contact patch, you have less surface in contact. So then you have more stress on that area, which then you now have a larger contact patch. So ideally, you want that height of that contact patch to be as narrow as possible to get that wheel to start rolling as easy as possible. So kind of same thing, you're limiting the lever arm that you got to get over to start rolling. The downside to going to a wide wheel is your maximum push force actually happens when your swivel casters rotate around. The wider that wheel is, when that caster starts to swivel, the inside part of the wheel and the outside part of the wheel want to rotate at different rates. So basically, you then have to fight the friction of that wheel trying to scrub against the ground as the caster swivels. So wide wheels don't work real great in a swivel caster application because that scrubbing force is so much greater. So that's where in the industry, you'll really see a lot of balloon tread wheels as ergonomic wheels, because even though that contact patch has a higher height, so it makes it harder to start rolling, it has less scrubbing. So when the caster swivels, it ends up being a better solution. Which then leads me into the wheel style. So, you have these flat tread wheels, you have round tread wheels, and then in the last, say, 10, 15 years, you've seen more split tread wheels. So split tread wheels allow you to take advantage of wider wheels and then reduce the amount of scrubbing, because now you can stack these individual rotating discs together. So then as that caster swivels around, each of those discs can rotate at a different rate and really reduce the amount of scrubbing. So that pretty much covers it for the main types of wheels that you're going to see out there. Next, wheel material, or the tread material. So again, it's all about trade-offs. And, we like to say this one's the Goldilocks principle. You can't be too hard, you can't be too soft, you got to be just right. Now, ideally, the harder the wheel, the easier it's going to roll. The problem with that, say I went out and got a steel wheel, I heat treated it as hard as I could, and that's going to make it really easy to roll. The drawback is I'm going to tear up my floors. So then I'm going to have a cost of repairing my floor every year or 6 months or something like that, and just have this tremendous cost. So then if you go to the opposite side and say, well, I'm going to protect my floors, I'm going to use a really soft rubber wheel. Now the problem is now you have a very large contact patch, you have to fight that scrubbing. So what we find is kind of the ideal solution is this polyurethane tread in the 85 to 95A hardness range. And then even, within urethanes, I mean, there's tons of different urethanes with different chemical properties and physical properties, where what we're looking for in a urethane is one with high rebound and also high tear strength. So we want something that's very tough. And then the rebound is, when it's deformed, how much of that energy does it give back? So think about a bouncy ball. When you drop it, how high does it come back up to its original drop point? The higher the rebound, the closer it's going to get back to that original drop point. So now that you know what you're looking for in an ideal caster, how do you put them on your cart? So in this case, what we really see a majority in industry is this 4-wheel caster steer. So it's 2 rigids in the back, 2 swivels in the front. It can be towed around a facility because of the rigids. It has decent maneuverability, so you can't pivot on center. And because you have casters in all 4 corners, it's a very stable system. The other style we see a lot is this diamond configuration. And there's 2 types that we see there. So there's one where all 4 are in contact. So you still have the 2 swivels in contact, the 2 rigids in contact. And then the benefit of this is it can pivot on center. So say you need to work off one side of the cart, pivot it around, work off the other side. This is an ideal setup for that. The downside is, depending on where your weight is situated, it can be a bit unstable. Say if load gets concentrated in a quarter, you could have a tip hazard. Now, the style that actually minimizes push force is this diamond tilt style. So that's where your rigids are slightly taller than your swivels. So then when you start to move it, really the swivels are just acting as tip prevention. And all you need to do is get the rigid or the fixed wheels to start rotating. So then you remove any extra scrubbing or drag from the swivel casters, and you can really move a lot of weight that way. So now that I've covered that, I'm going to go into a couple case studies. Any questions so far?
Yeah, we can open it up to the panelists.
Doug, wouldn't it also be true that on the harder material on the casters are also more prone to picking up debris that might be on the factory floors?
Yep, that is true. So the harder the wheel, like with a nylon or some hard plastics. So while they might be easier to roll initially, what we find is they tend to pick up debris. So because they really don't have a lot of rebound, debris will get stuck in there. And while it performed great on day 1, by day 50, it's covered in junk and it barely rolls. So that's the other nice thing about urethanes, is because of that rebound and some of the properties, they tend to reject debris better. Now, certainly you can get some cheap urethanes that'll act just like a hard plastic, but you know, the really high quality stuff will reject that debris as well.
And then on the flip side of that, if you go too soft and the cart has got a lot of weight and stays in a park position, they tend to want to flatten out and cause flat spots in the wheels,
Yep.
which can affect your rolling. So it's very important to understand that load balance. It's not just the turning and the mobility of the cart, but how long does it sit still with that weight on it as well. So
Yep.
there's definitely a science to it.
Do we have any research, or do we know like the lifespan difference between the urethane casters versus, hard plastic? Is it 1 time, 2 times more?
Well, I mean, this is where it gets tough because every application is different.
Mm-hmm.
But where, I mean, you could have a hard plastic wheel and it could pick up debris. And if you don't necessarily care about push forces, I mean, you could just keep using it, right? I mean, you could have workers struggling, so it could still last a really long time. But in terms of urethane wheels, I mean, we've had urethane wheels in operation for, 10 years and they still look like they're brand new.
For sure.
Yeah. And if you don't mind, I'll speak to that too. The other issue is when you've got that hard caster that picks up the debris, even if you're not manually moving and it's only being moved by mobile equipment, that constant bump will actually start causing the outside of the wheel to separate from the hub. And now you're metal on concrete and tears up your concrete floors. So it is, like you said, it's more than just harder to push, but even if you're only pulling it with mobile equipment, it can definitely deteriorate the lifespan. I've seen a brand new caster, put out on the floor and it lasts less than 6 months and it start pulling away from the hub.
Yeah.
Let me, if I have a question, we're getting ready to, one of my jobs is I work in heavy construction. So we're getting ready to put down the floors needs to be immaculate and needs to stay in shape. It's an epoxy floor, and it's one of the most precision products or processes you can have. And what from that perspective, so you may have something set for 2 months, but you don't want to scar up these floors because we're getting ready to, they're a couple of $100,000, and we plan all of our work. It is the last thing we do. And when we go into these other hangars and you see them sitting there, what is there an application that meets all those needs? You don't want to mark the floor up. You don't want to, that's something I see literally every day.
Yeah. And I mean, that's where this, from a marking standpoint, urethane's usually non-marking. But where we usually see the issues with marking up epoxy floors is what Dale alluded to with harder wheels picking up debris.
Right.
So they'll pick up debris in another area of the plant. They'll start rolling on these epoxy floors. And next thing you know, you got gouges and cuts and everything else because they got, they're covered in metal shavings.
Right. Yeah, that's and it's odd because as we planned this, we actually had the person that's putting it down who owns the epoxy flooring company, and I asked him, I said, what kind of casters do you recommend? And it was just not that we're going to recommend casters until the process is up, but the guy didn't know. He literally, so I was thinking, well, what an opportunity, to be more of a value add, to understand that, let me tell you how to take care of this floor, because they're walking out and these things are literally hundreds of thousands of dollars, to get them wrapped. And so I didn't mean to run off with that, but I always look at that and I see these beautiful floors with these cuts in them. And it's like Dale said, I can see it now. You run over a shaving and then thump, 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 thump. It's like that grocery cart that I drew the unlucky grocery cart, bam, bam, bam. And so, you see it on, heavy equipment, heavy engineering, so.
Yeah.
Anyway.
And really, I mean, we see this more in aerospace, but a lot of the times we'll be given a max floor stress that we have to design around. So say, like with the epoxy, how much load can that epoxy actually take?
Right.
In terms of PSI.
Right.
So if we're given a number, we can actually design the caster around that number to make sure that it has the correct footprint while still doing things to improve rollability.
And to carry that a step further, Steve, even if you don't have an expensive floor and it's just a standard concrete floor, most of your large factory floors are just large square slabs that are kind of, married up to each other. If you've got too hard of a wheel right there where those concrete slabs connect, it'll start chipping away at those edges. And then before you know it, you got poor floor conditions. So now you've got the floors tearing up the wheels tearing up the floor. And you're talking some major dollars when you have to cut an entire section of concrete out, have it re-poured, the amount of downtime, set time. It gets really expensive even on a standard concrete floor. Not careful.
Yeah, we do it all the time. You're exactly right. And the other thing is when you chip that out, then the forklift comes down, flying down through there. Now you have a pothole. So, it literally, it's a magnification, but the root cause is downstream and you had the wrong application with for your environment. So anyway, I'm gonna go ahead, Doug. I apologize.
Yeah. So I have a couple of case studies here where I show you how we use these different design elements to create solutions. So the first one, this is a tread cart. When we got this, they actually shipped it to us to do some testing. It weighed 3,500 pounds. This was a diamond tilt style, and it initially required 200 pounds of force to even get it to move. So we're talking about they were using 4 people to move this thing, and they're moving these things all over the plant every day. So obviously, I mean, they're looking for a solution, right? They can't have 4 people moving these things when they have 100 of them in the facility. So the one thing is we can't switch from the diamond tilt style. In this case, they had a lot of ramps they went up, so they needed that tilt to be able to get up the ramp. So knowing that, and knowing that the swivel casters really weren't going to play much of an impact on the ergonomics, we really focused on trying to expand the middle wheels, the rigid wheels here in the center, and use that principle of wider is better to reduce that contact patch. And then in this case, you still got to be able to rotate it. So then we went to a split wheel design across the middle of this, and we were able to reduce that push force down to 40 pounds. So they went from 4 people to now they had 1 person moving these things around just by improving their center wheel.
Well,
So next one, this was a cassette cart, 1,900 pounds. This was a diamond style, but all the casters were in contact. So in this case, it was 80 pounds to get this to start moving, and they'd had multiple injuries reported at multiple facilities. So in this case, since the swivels are touching the ground, we know we have to address those. So in this case, go into a maintenance-free swivel section with the high precision, the high hardness, and then looking at the wheel material. So in this case, it was also a pretty abusive application. So in the slide before, you see this green urethane. So this green urethane is the most ergonomic, has super high rebound. It's just not as tough. In this case, we had to go to a different urethane that was slightly harder with really high toughness. So we gave up a little bit on the rollability for better toughness. But combined with the swivel section, we were still able to get that push force down to 35 pounds. And they've been using these now for 7 years, and they haven't had any injuries since. So again, using the principles of better swivel section construction, better tread material, and we're able to make a large impact on the ergonomics. So what I really want people to take away from this is, there really isn't one solution out there for every single application. If you have a material handling issue where, you know, you're struggling to move something, there's a lot of different ways to go about solving it. And really it starts with the right caster, getting the right swivel section design, something that's very precise, has good wear properties because it's heat treated to the right specs, has the optimized swivel lead. You know, looking at your wheel design, you want to make sure you're going to the largest diameter you can. And then, you know, look at that width. I mean, if you're just going in straight lines, wider's better. Otherwise, you might want to consider a split wheel design. And then with that Goldilocks principle with the tread material, finding that right balance of rollability and toughness, you know, that doesn't destroy other things in the facility. And then just putting them on the cart in the way that's best going to suit your operation. So that's all I had. And, you know, if you're working on a material handling application where you're designing a new cart, these are the things that you should be asking questions about. And when you do, you should be able to get some sort of testing data. Like we have a huge database of tests that we've run, where if you say, hey, I need to move 3,500 pounds, we can say, these are the 5 or 6 things that we've tested that we know work. And it's usually some combination of what I've talked about in this presentation. So that is what I have. So thanks for listening and sharing in my passion of casters.
Yeah, thank you so much for sharing. We will let the panelists ask a few more questions and yeah, get those answered. Steve,
All
I
right.
think you had your hand raised. Steve, did you have your hand raised?
I think Serge just submitted a question, Serge. You're
Oh yeah,
on.
he said, are the loads rated per caster or per 4 or 5 casters?
So a caster will have an individual caster rating, load rating. But when we're looking at ergonomics, we're talking about total loads. So in this case, like for the 4,500 pound application, I mean, each one of those wheels was rated for, I want to say like 4,200 pounds. So there's a lot of safety factor built into it. But when you're talking about rollability, you have to go kind of above what the load rating is to be able to get the best rollability. So that's also a mistake that people make a lot too, is they say, hey, I have a 2,000 pound application. I'm going to get a caster that, you know, carries 500 pounds because I'm going to assume everything's evenly loaded. And then I end up buying something kind of small and chintzy and I put it on there and then it doesn't work the way I want it to work. So the first thing you should be doing is dividing that load by 3, because 3 points make a plane, and no floor is perfect. No, you know, welded frame is perfect. So even those 4s on there, really only 3 are going to be touching at any given time. But then that's where, you know, when trying to find a solution for a specific weight in terms of rollability, that's where you have to rely on some of the test data to show how things work at different loads.
Yes, sir. Thank you.
I have a question, and it's kind of a twofold. I was going to see if I could get Greg Pitts to jump in on this, because he's kind of a expert on cost of injuries and stuff. You were talking about a 7-year investment, and I'm just curious as to what something like that costs. And then I was going to see, you know, Greg, what, you know, back injuries, shoulder injuries, those kind of things, if you don't mind, chime in. And
Sure.
because people don't understand the ROI behind, your casters are cheap compared to, Greg, take it from there, please.
Yeah, I mean, you know, your shoulder injury is going to cost you 80 to 100,000 a pop, and your back's going to be 100 plus, maybe 120 plus, easy. And so it's the end result of design. If you can prevent one back injury, it's going to say not to mention just the efficiency of the work. You're going to speed the work up, make it more safe. I had a question, and I listened to you talk. It's very interesting. Do you actually help the consumer, the vendor, talk about where you place the point of contact for the employee, the height, the type of handle? Do you help them make that decision as well? Because I would think that would also impact the injury rate, as it impacts impacts the back, and how it impacts. And I'm sorry, I missed the first part of your conversation. You may have covered that, but that's a big portion that kind of coexists with the caster. I would think the total package.
Yeah, usually we leave that to the customer with their cart design, because they'll have internal standards on how high the handle needs to be, and then the cart manufacturer would make it to their standard. But to your point, even in those Liberty Mutual material handling tables, you can plug in different handle heights, and it'll give you different risks based on the handle height you put in too.
Yes. And you know, I've been around a lot of companies, and I do a lot with a real big company that's just like super ergonomics, and they do everything top shelf. But then there's vendors that supply the super animal that has no standards. You know what I'm saying? And so that's why, as we see both ends of the spectrum, and they have no concept of where a handle should be, or what type of handle it should be, or you know what I'm saying? It's just all over the place. And so that's why I was just curious if somebody asks you, can you help them with that? I guess the question.
Yeah, we would have the knowledge to be able to help them with that.
Perfect.
If you don't mind, Doug, I'll add to that. Even if the carts are already pre-designed when they get there, they do a lot of, and I'm speaking from experience, they do a lot of work with you. If it's not just the caster, sometimes it's the width of the base plate that's going on there to help center the load. Taking measurements, they're asking the great questions that they ask that you wouldn't always consider. Doug alluded to earlier is the unbalanced load of the cart. They're saying, hey, is at any point is this transported with all the load to the left, all the load to the right? So all those variables are taken into consideration when choosing the caster for the cart. So that has always been extremely helpful, because a lot of times you walk in, that cart's already designed, you're kind of stuck with it, but that it's more to it than just a wheel.
Mm-hmm.
Hey Doug, I got a couple questions, if you don't mind.
Sure.
It's specifically around your how do you say it? Twergo?
Twergo, yeah.
I think that is honestly a phenomenal concept. And is each one of the individual stacked wheels independent of the other stacked wheel, with its own bearing?
Yeah.
So that they can all spin independently?
Yep.
Because you think of when you were talking about a flat caster and how the inside and outside want to turn. I assume that offset works in the favor of being easier to manipulate and twist, right?
Yeah. Yep.
Do you ever find that because you have the channels between each one of the independent casters that sometimes it picks up more debris, or because of them being able to rotate independently, it kind of offsets it, and it's better for maybe an offset floor or a rougher floor with a lot of debris on it?
Sure. So we do get that comment a lot from people that have not used split wheels or Twergos. So they're like, well, won't stuff just get stuck in between? I'd be lying if I said it never happens, but it happens very, very infrequently. And what we actually find is, you kind of alluded to it, is because the discs spin independently, if something does get stuck, it works itself out.
That's what I assumed too, and I thought that was one of the most brilliant things about it. If you're working in a dirty shop and they don't have a perfectly laid floor, it even helps going over cracks or uneven floor surfaces, something like that. My other question kind of pertains to your actual swivel sections.
Yeah.
I saw on your site you guys have a dual swivel section part you can go into, and you didn't touch on that too much. Do you ever find that people, with something like that, I would assume, your friction is very, very low. People think that it's sometimes hard to control.
So you'd be referring to what we call swivel on swivel. So it'd be two swivel sections stacked and then offset. And From an ergonomic standpoint, it does help if you're trying to go 90 degrees with a cart. So say somehow like normally the cart gets dropped off and then the swivel casters are pointed at 90 degrees instead of in line or at 180. So having that second degree of freedom actually allows you to get a little momentum going to break that 90-degree state, because that is the most difficult one to get moving, but it's also very rare. So it does have some benefit to ergonomics, but where we really use the swivel on swivel is more in powered applications.
So
Because
something like an AGV.
like an AGV, because it increases maneuverability. And one of the maneuvers that's really tough to do with casters is you're going in a straight line, you stop, and
Right.
then you reverse. Those casters swivel around, they fight each other, they add extra drag to the motor, and one, you got to oversize the motor, you use more power. Whereas if you have a dual swivel section or swivel on swivel, you really reduce that castering effect and can move, do that maneuver, that stop, reverse with much less power.
Got it. Yeah, I didn't even think about a powered application. But no, that's pretty much all I got. I think those Twergo casters are just insanely cool, honestly.
Yeah, but I think we came out with ours in 2014 or so, maybe 2012. And before that, the entire industry was either the flat treads or the round treads.
Right.
And now it's probably 50% split wheels, if not more.
Is your green color a component of material, or
Yes.
can you put different material on those?
So the green is a certain type of urethane that we use. So it has the highest rebound, so it has the best rollability, and I'd say it has like medium toughness. And then we have other urethanes that have lower rollability but higher toughness. So then it just depends on the application, how abusive it is, on what urethane we want to use.
Got it. That's all I got. No, I appreciate it, man.
All right, great. Thanks, Zach.
Got a question for you, Doug. As technology continues to expand and we see more and more automated products in the environment, and I see a lot of them. Where is it going to be in the future? Is there going to be sensors in the wheels, sensors in the caster, sensor in the stem that's on that can sense how fast they're moving, what they're doing? Is that you're working on? I'm assuming you're probably working on something like that now, because I see so much happening. I can see it becoming almost totally automated, and I'm just curious where you see the future going with this.
Yeah, I mean, certainly with more automation. Just with the rise of automated guided vehicles, the last 5 years, it's been incredible. Again, that goes back to the labor shortage. You don't have people to tug stuff around facilities, so now we got to find a way to automate it. A lot of those systems do have built-in sensors to track. Caster position isn't necessarily important, but it will track like speed and stuff like that. We've been doing powered systems for probably 6 or 7 years now, and we don't do anything totally autonomous. They're still human operated, but we have some omnidirectional systems where the casters have to monitor what position they're in, because that's how they do the omnidirectional steering, is they all move into the correct position as you're trying to steer it where you need to steer it. So yes, there's been a large increase in the number of sensors and everything else that you have to use to do that.
Awesome. We have any more questions from the panelists? Just check.
What is the impact of a dirty environment with oils? How do you handle different types of chemicals? And does your casters, the different ones, act with different chemicals, oil versus, kerosenes versus gas? What is there? I'm just curious.
Yep. So in those situations where we know there's substances like that on the floor that the wheel's going to come in contact with, we'll gather that information, then we work with our urethane supplier to figure out what's the optimal material that's going to best withstand, those chemicals.
Awesome. Thank you.
Yeah.
Sweet. Well, if we don't have any more questions, I'll go ahead and share my screen. And we'll turn it over to Steve to give us a few last words. And once again, Doug, thank you so much for this presentation. And we're going to get it recorded and sent out to hundreds of people.
Great. Yeah, thanks for having me.
Go ahead, Steve.
Yeah, thank you, Ray. Ray is our he's our mission controller, and what I really wanted to say is thank you to all of you. We committed to this process of educating people, and it's free. You go take a look at it. But just a little bit about my passion with casters is, again, I work in a couple of different areas, but I see more misapplications of casters, and it's from I'll go grab 4 casters out of a bin at the hardware store, or there's just no rhyme to it. And then again, like I mentioned, we're putting down this, it's going to be a beautiful floor. These epoxy floors are beautiful, and they're designed for specific things, and you look at them. And when we started looking at this, I worked with another construction ergonomist. His name's Noble King. He's super good. And when we looked at doing this, I was looking at the different organizations, and I was like, we don't want to build a caster training program. That's not what we do. I put a little posting out about my mom and making biscuits, and the people that do what they do. So we reached out to Caster Concepts for a reason. They've got strong engineering. They've got lots of years of engineering. And when we had our meeting conference, everything we've done to put this together, they've been super reactive. They operate like a lean company. And so Doug, I can't thank you enough, and Tyler, George, you too. We've moved through the process quick. So thank you on behalf of the Ergonauts. And
yeah, absolutely. We're happy to do it.
Yeah, and our panelists, you've all committed to being with us and sharing, and that's what we want to do, and that's what we need to do as an ergo community is do that. And I love that, when you look at the cost of one injury, and you've had a solution in place, you built a solution out with the company 7 years ago. It's kind of hard to measure what didn't hit you, but all it took was one of those, and you solve that problem. So that's what we're trying to do, is we want to help be part of the solution. I hope that somebody sees something. The other thing is, we have no financial arrangement with Caster Concepts. We're 2 independent companies. We just asked them for help, and they extended their hand. So we're not here to sell you casters, but I will say this: if you are looking for solutions, that's who I would contact today. Doug I think he had his contact information up. He's also on LinkedIn, or you can search their company, Caster Concepts, on LinkedIn, and they're doing a lot of cool stuff. So our sponsors, we call them our sponsors because these are companies that we love, and we have do a lot of work with, but they don't pay us anything. So this is genuinely free. We love Superfeet, and they're a great company. They're trim to fit orthotic, and it's all about your posture. Commonwealth Hand Therapy, that's Dr. Pitts' company. He's got multiple PT and OT outpatient clinics scattered throughout the beautiful bluegrass state of Kentucky. Algo office is our lean product that we use to evaluate processes. Atomic Ergos, our podcast, we've done 17 this year. We have 17 podcasts, and if you want to know what the future of ergonomics looks like, the people that we've interviewed have give us a good peek into what we need to be doing. Ohm seating is a great product. We love them, and when the chair hits your door, you can literally have it assembled by yourself within 5 minutes. Of course, Caster Concepts, again, thank you. We look forward to having an opportunity to work with you. But I would say to every company out there that's doing ergonomics, they're an open door. So we reach out. And then this is Kirby Mask. This is his consulting firm. Kirby's CPE works with us, and we love Kirby. And if you want some super heavyweight ergonomics, Kirby's your guy. So, and then iHealth 360, that's a friend of ours, Lanisha, and she's got a up and coming company. So that's all I got. I just can't express enough gratitude. Happy holiday to you, whatever you want to call that. But I hope everybody has a safe holiday, and I hope that 2024 that we're all sharing the blessings that have been bestowed upon us. So that's all I have, and please speak up if you want to share something with us, and if not, then we'll call it a night.
Merry Christmas, everyone.
Yep.
Merry
Yes,
Christmas.
Merry Christmas.
Thank you.
Yep, thanks.
Hey, do have a quick story I'll share if you guys
Yeah,
have
go
a
for it.
minute. Just talking about the importance of casters, the whole world of ergonomics revolves around people, right? Sure, there's a science, but at the end of the day, it's about people and taking care of people. And my former employer, we had 4 different cart designs, which was over 500 carts. All 4 of these designs range from anywhere from 85 pounds of push force up to 120 pounds of push force. We had females that were trying to move this that didn't weigh that much.
Yeah.
And had and it was Caster Concepts that came in and helped me find a good caster. The Twergo caster is what we put on there. And when we had these in trial mode on this particular cart, every morning I'd go by and talk to the operators, and I'd say, "Hey, how do you like those new casters?" And every time I'd ask, they would smile real big and, "Oh, we love them. Oh, thank you. It's so nice not to go home hurting. The shoulders are not sore." And I'm, just kind of walking around, my chest stuck out, thinking, "Oh yeah, good big win." I came by one morning, I asked a gentleman, I said, "Hey man, how you like the casters on the cart there?" He said, "I hate them." And I said, "You hate them?" I said, "What do you mean you hate them?" He said, "Let me show you." And he grabs the cart with the Twergos on it, and he starts pushing it over to the stationary location where they're stored very easy. And I'm like, "What's this guy talking about?" He pushes the cart against the wall, turns around, walks about 5 feet toward me, stops. And I was like, "What's the problem?" He said, "The cart's following me, isn't it?" And I turned around and looked, and sure enough, the cart was actually rolling behind him. The casters worked so well that it wouldn't stay still. It went from hard to move. I can't move the cart to I can't keep it still. We actually had to put bump tape down because the floors weren't level to keep those carts from just rolling on their own. So it was a good experience.
Oh yeah, perfect story.
It's amazing we don't think about the fatigue factor. And if you're working at a voluntary effort of 70, 80, 90% of what you can do, and you reduce that way down, and you go home at night, you've got energy to do other things.
Yeah.
If you're working your hind end off during the day, and that's the difference. It's not just the injury, it's also the fatigue factor that
Absolutely.
plays a big role in quality of life.
The morale, big time.
Mm-hmm. Yeah.
Wow.
Yeah, thanks for sharing that, Dale.
Yeah.
Appreciate the opportunity to be on the panel tonight.
Yeah, thanks, Dale. Thanks,
Yeah.
everybody.
We appreciate you, and we hope you want to work with us in the future. Thank you so
Absolutely.
much. Yeah.
Have a good night, guys. Thank you.
Yep,
Bye.
bye. Good night.